So welcome back to the third part of the presentation on the fixed income risk and reward. So as we were discussing, there are the concept of yield curve itself. I think I have already detailed that in my preceding lecture and the preceding videos. In fact, even the preceding part or the last part of this video itself also I have detailed about it. A couple of things which are of important that this duration measure are are a couple of couple of types. So one is, as I said, that what happens to the reference bench curve. So whatever happens to the reference bench curve, that has a cascading effect on the final yield curve. The measurements pertaining to those uh, changes that occur at the reference benchmark level are called the curve duration statistics, and the duration measure mostly connected or mostly associated with curve duration is the effective duration. Okay. And the other part, basically the spread measures that contribute to the final yield out here, they are measured through various other duration measures in the form of the Macaulay duration, modified duration, and the PVVV. So this is the main distinction between the two. Now, why it is so, we will come to that a little later on as we cover the need for distinguishing between the Macaulay modified PVVP and the MVBP and that of the effective duration. So we will discuss them at detail why this distinction is required. Suffice to say, as far as this particular slide is concerned, know this, that there is a distinction between these two sorts of duration measure. If the change to the yield curve is attributable to the changes in the reference bench curve itself, so we will make use of the effective duration. If the changes are pertaining to the changes, the stackable yield measures, the component stackable yield measures, then we will refer to the MAC duration or the modified duration itself. Now, here we will not quite again detail what is the duration, what is the price yield, the trajectory, and stuff like that. I think that would be quite a repetition, and this chapter unnecessarily will become much more lengthier than what I had actually envisaged, set out to. Uh, just know this, that how the duration graph actually differs between a straight bond and that of a bond embedded with options. So as far as a bond which is a straight bond, let's say a fixed coupon straight paying bond, that's what we will say as a straight bond. So that bond will have a duration graph something similar to this. Okay, so if there be a little bit of price decrease, the value of the security, fixed income security, will go up, and if there be a little bit of if there be a little bit of price decline if there's a little bit of interest rate increase, the security value will proportionately come down. We all are aware of it. That's how the duration measure works. That's what the duration measures. However, this same concept is not quite followed when it comes to bonds that have embedded option in them. For instance, a call option. Now, as we know that the call option accrues to the bond issuer and at the discretion of the bond issuer, and as per the schedule that are published in the bond prospectus itself, the issuer reserves the right to call them. Now, for such a situation, whenever the market interest rate comes down, the propensity of the call option coming into money, that is the issuer actually calling the security and making an accelerated early redemption, becomes that much a reality. So when that happens, the market obviously is not going to value a bond embedded with a call option in the same fashion, which otherwise is an identical with a fixed rate bond and but does not have the embedded call option in them. But natural that the market will cap the value of such a bond even with the interest rate declining to a substantial level to its strike price of the call schedule. So beyond a certain price, um, the price of the bond will not increase further, even though the um, rate of interest change may become substantially low because the bond will eventually will be called. So for such an instance, the duration graph is not as uniform as that of the straight coupon bond, as we see that it's capped here. Exactly the reverse thing happens when we are talking about a bond with an embedded option but being a put option. The put option, obviously the benefit accrues to the bond holders, and in such a situation the the market obviously is going to value this security more than what it would otherwise a straight bond, right? So this is the primary difference between the two sorts of options embedded in security. However, we are now typically interested that what the duration measure should we use for bonds with an embedded option. So from these two curves, we understand one thing, that with the rate of interest rate changing continuously, even by the minuscule fraction, even by a minuscule fraction or some substantial portion of it, the traditional duration measure, which measures the duration based on the yield curve itself, yield curve movement itself, will become meaningless because of the embedded option. So in such a situation, we focus more on the reference curve, right? Because the reference curve is unaffected by the movement of the interest rate, other than what has been defined in the duration measure of the treasury securities itself, because there is no concept of embedded option in that. So bonds which have embedded option in them will not have a very well defined cash flow, and precisely why we will make use of the effective duration for such an instance. In all other aspects, bonds that do not have the embedded option in them, we can make use of the modified duration or the MAC duration measures. Now, one more type of bond that has a characteristic very similar to a bond having a call option or a put option embedded in it is that of the mortgage-backed securities. And because the mortgage-backed securities have a substantial prepayment risk, we have covered this in our preceding chapter in detail, which potentially may force an early retirement of the bond because of the prepayment in the hands of the borrower. So in case of a mortgage-backed security as well, the cash flows are not that well defined. So in such a situation as well, the use of the Macaulay duration or the modified duration actually becomes meaningless. And the use of effective duration is something of importance here as well. So in short, the effective duration is deployed for those securities that do not have properly defined cash flows whenever the market interest rate changes. This is the only important key takeaway for this entire exercise. Now, however, there is a small caveat to that as well, and that is that how long this can happen. In my last chapter, I had detailed about something called as the call schedule, and I have demonstrated that why an entire issue is not called at one go, even though the interest rate may decline substantially. And there are call schedules because the call happens, the bond retirement happens as per the call schedule. So there is a yield to first call, yield to second call, and stuff like that. We discussed that at length. Now, please do understand that if the interest rate change is minuscule, it's very low. So in such a situation, that even though the bond may have an embedded option in them, the difference may not be really much. The difference may not be really much between a straight coupon bond and that of a bond with an embedded option. Okay. So one thing that we understood is the change in interest rate will have to be something substantial that increases the probability of the issuer to call on the securities. So that's one important aspect. The second important aspect is something called as the refinancing burnout. Now, this particular aspect is not really covered in your CFA level 1 curriculum, but I think that it beggars some sort of mention while I do the explanation. And that says that once the interest rate actually declines, many of the especially true for the MBS security holders, wherein the borrower would retire a substantial portion of their interest of their principal outstanding. However, if the rate of interest keeps on changing, keeps on dropping, uh, the borrower may not have enough outstanding principal that they would like to retire at one go. So that means that a time might come wherein even if the interest rate declines substantially, that perhaps will not quite herald the borrower to pay back their principal outstanding. So which means that at a very low interest rate, especially for the MBS security holders, the risk that the entire principal will be retired with the subsequent decline of the interest rate, well, that actually decreases. That does not become quite significant. It is only at the first go itself, first or second go itself, when the interest rate declines substantially low, that the bulk of the prepayment happens. So, considering these two things, what can be safely said is that the use of the effective duration and the use of the other duration measures, for example the MAC duration or the modified duration, in lieu of one another, it only would make sense when the rate of change of interest is substantial, and it happens, one is it is substantial and it happens instantaneously. So these two are actually paramount importance, that would necessitate, that would actually warrant making use of the effective duration. Other than that, if the change of interest rate is minuscule in nature, or it happens gradually over a elongated period of time, use of effective duration or use of any other measure of durations will yield the same or similar results. So here I have actually worked out a problem regarding how the Macaulay duration and the modified duration are actually constructed. And a similar kind of example is actually there in your CFA textbook as well. Here, what I have done is I'm going to just explain the mathematics behind it, the calculation part behind it, rather than me again doing the calculation itself. And it's very easy. It's not that difficult. But this understanding is paramount, because this would lay, it will actually, lay the foundation for your future understanding of the duration measures. So typically, let's take an example here. The example says, consider a bond proposition under three different circumstances. Bond 1 and 3 pay 7% coupon annually, 7% coupon. So this is bond 1 and this is bond 3. They pay 7% coupon annually and originally issued for 5 years on January 1, 2021. So these are the 5 periods the bonds have been issued. On January 1, 2021 was the first date that it was issued. Okay, and all of them yield 5%. So the market interest rate are 5% here, 5% here as well. Now there is a third bond which is known as the bond 2. It is similar to the bond 1 and bond 3, but with the small difference of it being a zero coupon bond. Okay, and the second difference is that this security was purchased in the market, or is being evaluated for purchasing in the market on July 3, 2021. So we have 3 bonds out here. So this consideration is for January 1, 21, the day the bond was issued. This consideration is also for January 1, 21, and the second bond, the consideration is July 3, 2021, almost exactly 6 months, 2 days later, 3 days later. All right. So what we are set to find out, we have set to find out the Macaulay duration and the modified duration in each of these bonds using the traditional cash flow method. So as I have said before, that the only definition of duration as far as Macaulay is concerned is that you must remember that it measures nothing else and nothing more than how soon and how fast can you actually receive your promised cash flow. And the same concept we are going to drill down, and we're going to demonstrate mathematically how it actually manifests. So let's work through this example with the bond 1 itself. So we are to calculate the Macaulay duration at the day the bond was issued, because this is January 1, 21. So we have 5 periods, 1, 2, 3, 4, 5, and the coupon is going to be paid at the end of each year itself. It's an annual pay coupon, and this is the cash flows, 70, 70, 70, and the last cash flow obviously is going to be 1070. So if you add all of that, this is the total yield that you're going to get, and the rate of interest is 5%. So what we do is that each of this coupon, we can always discount them by the rate of interest or the discount factor itself, which is the YTM. So if you discount this particular coupon of 70, this is going to be discounted for 1 period. And if you discount this by 1 period, that is, this math is 70 divided by 1 plus 5%, right? So if you do that, this is what you get as the present value of the cash flow, 66.67. Similarly, if you discount the second coupon for 2 periods, because this has been received at the end of the second year. So the math out here is 70 divided by 1 plus 5% to the power 2. So the present value of that comes out to be 63.49. So in a similar fashion, if you work out all the cash flows and add all of the cash flows, so the present value of this cash flow comes out to be 1086.59. This is exactly in an equivalent manner. Mind you, I'm not saying exactly the equal, I'm saying equivalent manner. The proceeds which you are going to get over the period of time, including your principal or the face value at the end of the tenor, that present value of those cash flows under the given yield to maturity and the fixed coupon that you will be receiving is 1086.59. Fairly easy to find out. Now, what we need to do is we need to find out the weight of these cash flow, each of these cash flows. So how do we do it? All that we do is 66. I'm just working out the first cash flow, 66.67 divided by 1086.59. So if you do this math, this comes out to be the weight, which is 0.061354, which is roughly about 6.135%. Similarly, if you talk about the second cash flow, the weight of the second cash flow is 63.49206 divided by the 1086.59. The weight of such cash flow comes out to be 0.058432 or 5.84%, right? So accordingly, if you add all of them, if you weigh all of them, this is how it looks. Obviously, if you sum all of them, the weights are going to be 100% or equal to 1. Now, the last step is important because this actually is the cornerstone of how the macular duration is being calculated. What we simply do is that we multiply the period with the weight that we have just found out. So accordingly, this becomes 0.06134 into 1. So that becomes 0.06134 itself. Similarly, 0.058432, if you multiply this by 2, this comes out to be 11.11684 6864854. Okay, so in a similar fashion, if you go ahead and do the calculation yourself, you will be able to find out the weighted period. So weighted period is nothing but this weight multiplied by the period when the cash flows are being received. Okay, so once you have done this and you add all of them, that becomes your Macaulay duration. That becomes your Macaulay duration. So this is fairly easy. All that I've done is that I've weighted cash flows are there and simply sum it up, and it is coming out to be 4.414986, whatever. Now, rest be assured, do not get intimidated. In your exam, in your actual exam, it is very, very unlikely that any of these calculations are actually going to come in your exam. The exam is not going to test on how you work through the Excel skill. That's not what they are going to test about. But for your understanding, this is how the Macaulay duration is being calculated. In fact, if you ask your calculator as well, which does the job for you, that also is going to work accordingly. I have taught you guys, I have in my previous lectures and previous video, how to make use of the bond function embedded in your calculator. And if you make use of them properly, the calculator is going to throw you something called as the modified duration. From modified duration, you can always find out the Macaulay duration through the relationship that modified duration is nothing but the Macaulay duration divided by 1 plus current yield or periodic yield. So in this case, since we have already found out the Macaulay duration, we can pretty well find out the modified duration as well. All that we have to do is to multiply this Macaulay duration with the yield measure of 5%. So if you multiply 4.1498672 into 1.05%, that becomes your modified duration, which is 4.2. This is all the calculation is all about. So similarly, you can work out for a zero coupon bond as well, right? So in case of a zero coupon bond, you can see that there is practically no cash flows, internal cash flows, because there is no coupon as well. And the present value of the final lump sum amount that you're going to receive is 783.5262, and that's the way we have done it. I mean, that's what it is. It is fairly simple. Since you're going to receive the face value, all that you do is discount this face value of 1000 divided by 1 plus 5% to the power 5, and that becomes your present value thing. You did not do any more calculation, and the rest of the thing is very easy. However, where bond 3 actually differs from these two is that the settlement date, or the date on which we have to find out the duration. I'm sorry. This is, yeah, yeah. So yeah, yeah, correct. So this bond 2, sorry, the bond 3, just did a little bit of a mistake here. This is also January 1 because the period and the date are coinciding. This is also January 1. So this is a coupon paying bond. This is a zero coupon bond. This bond, which is a coupon paying bond, this is July 3. This is July 3. Right. So in this case, what is happening is on the day of July 3, we have to find out the settlement price as well as the modified and the Macaulay duration. So if you have followed my previous lecture and previous videos, you would know that how we find out along the glide path or the price yield trajectory, how do we find out the carrying value of a bond at a date which is other than the resetting date of the coupon or coupon itself, in any day interim between two coupons. So July 3 happens to be one such date. In fact, it can be any other date as well. Just know this, that June 30th was the last coupon uh, date. So just a couple of days have passed, and thereafter we have to find out the Macaulay duration or the modified duration itself on July 3. So all that we do is we make use of the day day count convention. So it is 183, purchase time is 183 days post issuance, and the day count convention is 3360. And we frame the same in the same fashion as would be the other two exercises that we have done, with the only distinction that the first day of the first cash flow that would be received, that particular cash flow we do a little bit of a tweaking, because um, uh, so it was an annual pay bond. So that means that the last cash flow was received on December 31. So the next cash flow is again going to be received on December 31 of the succeeding year. So December 31, 2020 was the last cash flow in the form of coupon that was being received. Since the bond is to be priced on July 3, 2021, the next coupon due is on December 31, 2021, right? So the period leading up to December 31, 2021 is around 0.49. This is the formula. I've already done this many a times. I'm not going to do the math again. Just know this, that from July 3 to December 31, there are about close to 186 odd days. Sorry, 183. Yeah. So it would be something close to 170, 177 days. That's how it is being counted. 27 days of July, and thereafter 5 days of 150 and 20, yeah, 177 days. So 177 divided by 360 happens to be 0.49. So only the first period of the next cash flow being due is to be calculated, and thereafter it is just in the resetting mode. Thereafter it is going to be 1.49. Watch how one whole number is being added to this fraction. So 0.49, which is December 31, 0.49 period away, and thereafter December 31, 2022 is 1.49 period away. December 31, 2023 is 2.49 period away. Like this, we have enumerated all the five all the five cash flows, all the 5 periods for them. Since the market interest rate is also not changing, the fixed rate is at 5%, and the coupon, as we know, is already 70. So all that we do is that since this was the only exercise that was an additional part, so that we did this, and the rest of the math is exactly the same thing which we have done in the earlier 2 cases. So we find out the present value of them according to their time period. So in this case, 70 divided by 1.05, which is percent, and then we put this as 0.49 to the power. The second cash flow, which is 65.096. So how we do it? It is 70 divided by 1.05. Here we will put the power as 1.49, right? So this is how we proceed. So once you do that, you'll get all the cash flow, and then when you sum, this is what it is, the sum, which is basically nothing but the equivalent present value of the entire proceeds. And then we find out the weighted cash flows. The way we find out the weighted cash flows, you know that. How do we do it? And we simply take out the weighted period out here. So when we take out the weighted period, which is the weighted cash flow multiplied by the period, so this 0.061340 multiplied by 0.49 comes out to be 0.0330. So similarly, 0.058432 multiplied by 1.49 comes out to be 0.087. So we do this math and then we add them, and then when we add, what we get is the Macaulay durations. As before, modified duration is nothing but multiplying the Macaulay duration with 1 plus the periodic yield, right? So I think this slide should be amply clear in understanding how the duration measures are actually gleaned out mathematically. What you're going to see this slide, and I hate to say this because none of my students are, none of the people that I actually coach, I train, I never advocate anybody to actually memorize or regurgitate formulas in your exam. I believe always that, if you're thorough with the underlying concepts, you need not practically remember formula. But there are obviously some exception where, and I would ask you to try and tax your brain with regards to only a few formula, and this happens to be that particular slide with a few formula which I would really want all of you to remember, memorize, and do whatever you want to do with them. Basically, but again, the science behind it, for example, Macular duration, this is called as the closed-end formula for Macular duration. Again, without dwelling much on it, suffice to tell that whatever we have studied here, as part of this, this is just a closed-end formula for that. So this particular formula, I would want all of you to make note of them. So a Macaulay duration, 1 plus R divided by R, where R is basically the yield to maturity. N is the period, of course, we know. C is the coupon. N is the period, as we have already said. And T is basically the time that has already elapsed. So for instance, in our last example that we just did the job out here, so in this case, since this cash flow is due as 0.49, so in this case the T is going to be 1 minus 0.49 or 0.51. All that it says is that on July 03, 2021, 0.51 period of a year has already elapsed. Okay. Second in line is modified duration. You're already aware of the formula. Modified duration, there is another formula to finding out modified duration, and this is how it happens. When to apply modified duration, you went to apply effective duration. I have already discussed. Money duration is nothing but the absolute value, finding out the duration. And the last important thing which I wanted you to find out is the convexity formula. Do remember that, at the cost of repetition, the convexity is nothing but the second order derivative itself, since the duration measures are linear in nature, and we do understand that what is being predicted on the linear scale and what actually is being observed in the market as per the price yield trajectory, they are not one and the same thing because of this curvature. And this extra curvature, the error term increases proportionately as we go on increasing the magnitude of the rate of interest, and that is exactly where the convexity actually comes into picture, because the convexity fills in this particular graph, because this the convexity is nothing more than the second order derivative of the duration itself. So approximate convexity, this is the formula that I would want all of you to remember this. And the closed-in formula for convexity for a zero coupon bond is n minus t. This is again a horrible formula which is there, but nonetheless, this is the only a time when I would actually emphasize upon remembering formulas. So student candidates, I would strongly advise take a printout of this particular slide, and this is the only slide that I would ever insist all of you to memorize by heart. As before, the price change of a bond is a culminating effect of dual cause. One is the duration effect, and the second is the convexity effect. Okay, so with that being said, let's attempt one more problem here. The Sao Paulo municipality issues a 10-year 8% semi-annual pay bond on 1st of June 2020. It is priced to yield 6.15%. Consider an investor settlement date as February 15, 2021, at which point the issue may experience a change in its yield to the tune of 12 basis point. Calculate the theoretical price of the bond. Calculate the theoretical price of the bond. Um, Calculate the modified duration of the bond and also the max duration of the bond once the modified duration is found. And under the change in yield, what are the money duration? Okay, so again, as before, as I always advocate that please do draw your timelines, and that should help in solving the problems faster. Okay, so we are talking about a 10-year period, 10-year semi-annual period, of course. And so on and so forth. Okay. So how many periods are there in a semi-annual period? There are going to be 10 into 2, 20 periods will be there. Okay. And how many coupons are being paid? Obviously, 20 coupons will be paid, and each coupon will be 4% of the face value. The market determined yield is around 6.15% divided by 2, which is 3.25%. So given all of them, face value, of course, by default is 100, we will assume. So given all of them, I'm sure that you can input the details in your calculator and find out through the TVM method of the present value of the bond. So if you do the math, the price comes out to be, the theoretical fair price of the issue comes out to be, I think, somewhere around 113.67. So this becomes my theoretical fair price of the bond. Okay, but this price is pertinent to t is equal to 0, right? That's what it is. Let me just do the math once again, because some of the calculations I have already done myself. I didn't want to waste time here, so I'm directly punching in the number. There could be an element of error, so time to time it is it's a wise decision to check on what has actually happened. Okay, so let me work out the problem here. So I input 20 as the number of periods, 4 as the payment each period, 3.25. Okay, just 6.15 is the, so this becomes, it's not 3.25, it's 3.075. Oops. Okay, that's where possibly where the error might have crept in. Let me just work it. So this becomes 3.075%. So I by y is equal to 3.075. I input that details as well. Okay, and the face value is 100, of course. We have done that. 4 is the PMT. Number of periods at 20, so we need to find out the present value. Okay, oops, something's not quite right with my calculator. Yeah, so it comes out to be, we were right, 113.67. Okay, no harm done. Time to time, it's a wise decision to check on what has happened, what are the details I'm working with. So this is the theoretical fair price of the bond, but this bond of this price of this 113.67 is as on 1st of June 2020 at the date of issuance. Okay, now we have to find out the now there is a problem here. That the problem is that the settlement period. So the actual period is, the settlement date rather, is somewhere around it is somewhere around 15th of Feb, right? So 15th of Feb, uh, 2021. So please understand that if a bond is issued on 1st of June 2020, the first year is getting completed on 31 May 2021. So accordingly, 15th of February will be just, on the right side of the middle period of the issue itself. So here we are. This is the day of settlement. Okay. All right. So the other details, what we are required to find out is to calculate the modified duration of the bond and also the MAC duration once the modified duration has been found out. So there are a few ways to finding out. One is that you can directly make use of your calci and find out the modified duration of the bond. And the other way of doing it is a more traditional method and being advocated by the CFA Institute is just to shock your interest with 1 basis point on the plus side and 1 basis point on the negative side in your TVM problem, and then do the math by yourself. So all that you have to do is instead of 6.15%, all you need to do is to make this 6.16%. You have to consider the 6.16% once, and then you have to consider 6.14% once. Okay, so obviously since it's a semi-annual period, you have to divide it by 2 for each period's interest rate. So this comes out to be 3.07, and this comes out to be 3.08. All that you have to do in your calculator, just input the IYY function twice, one taking up the value of 3.07 and in another taking up the value of 3.08. If you do that, then you will find that the price of the bond, and again you'll have to find out the price of the bond only. So the price of the bond, you will find once you lower the interest rate to 3.07%, you will find the price of the bond as 113.746. And if you shock the interest rate by 1 basis point, and that is 3.08% semi-annually, it will become 113.586. So one is 746 and another is 586. So we know how to find out the modified duration, and the formula suggests that it is book the bond value at change in yield on the negative side minus the bond value with change in yield on the positive side, divided by 2 into the bond value at the given market interest rate into the change in yield. By default, of course, when we calculate, we assume del y is equal to 1. So we will now just input this value 113.746 minus 113.586 divided by 2 into 113. 113.67 into, obviously it's in fraction, 1 basis point is 0.0001. Okay, so if you do this math, what comes out to be 113.746, that's we deduct 113.586, so you get 0.16. This now divided by 2, and this now divided by 113.67, and this now divided by 0.0001, which comes out to be 7.0379. So this is your modified duration. So once you know the modified duration, of course, you can find out the Macaulay duration, and the Macaulay duration is nothing but 1 into the periodic yield. So this becomes So the Macaulay duration in this case is going to be 7.0379 multiplied by 1 plus the yield to maturity has been stated as 6.15%. But since we are talking about the semi-annual, so all that we are going to do is multiply it by 3 into 3.07 1 by 3.075%. Okay, so we multiply this by which comes out to be 7.254. So we have got both the duration measures. So one is the modified duration and second is the Macaulay duration. Okay. So under the change in yield, the change in yield is slated to be 12 basis points. Under the change in yield, what are the money duration? So the change in yield is 12 basis point, and all that we have to find out is that what is the money duration. So money duration is nothing but the annualized modified duration, annualized modified duration multiplied by the market value of the security into the change in the yield expressed in the decimal point, right? Okay. So we have already gotten hold of the modified duration. We know what the modified duration is, 7.037. And the market value of the security also we have found out through this value and multiply that with the 12 basis point, right? That's how we do it. But having said all of that, if you do this exercise is going to be limited on June 1st, 2020 itself. The question is not really quite concerned with the June 1, 2020, but it is asking about the settlement date of 15 February 2021, which means that we ought to first find out the fair price of the bond, theoretical fair price of the bond, on 15 February 2021, and then find out the duration measure once again. The duration measure we have to find out at 15 February 2021, and then take the the absolute value of the security and the other aspect as well. So in this case, what we have to do is that first we find out the theoretical fair price of this issue on 15 February 2021, and assuming that the security is on the glide path of the price yield trajectory, all that we have to do is to multiply the period with the current yield itself. So the price that we found out was 113.67. Just multiply this with the 1 plus 6.15%. Here we need not again do it in a in a fractional, as in a semi-annual manner. We can directly take 6.15%, because what we are going to do is that on the power quotient we are going to fractionalize the period. So from June 15, from June 1 till 15 February 2021, the time period in comes out to be okay. So let's again, no problem. So let's do it on a traditional basis of semi-annual itself. That would also yield the same results. That doesn't quite matter really. So we will say this is 1 plus 3.075%. This to the power Okay, so I made a small mistake here. I think I need to correct that because this is a semi-annual pay bond. So that means that the bond which was issued on June 1 would have first made the payment on December 31st. It would have already made the payment. So from December 31, so first we have to find out from December 31 what is the total price of the bond. That first we have to find out, and then they have to do the calculation. So let me redraw this whole thing. Up to here, I think it should be clear, abundantly clear, that how the price of the bond is being found out at the day of the issuance, how the Macaulay duration is being found out, and how the modified duration is being found out. But all of these calculations pertain to the day of issuance itself. However, we are interested in the settlement date, which happens to be 15 February 2021, and we know that this is a semi-annual coupon paying bond itself. So the way we do it, we have already since have done a typical, similar problems before. So this should be fairly easy. Since we have to find out this is my settlement date, and so somewhere here, from June 1 to December 31, somewhere here the first coupon was made, right? Somewhere here the first coupon was made, and from here, then this is December 31, and from here 31st, the second coupon that will make, because it's a semi-annual. So first we have to find out that on this particular day, which is the nearest day to 15 February 2021, or the last coupon when it was released, what would have been the fair price of theoretical fair price of the bond. So here all that we have to do is to input n as equal to, instead of 20, we are going to put n as equal to 19, because after the first coupon is being paid, there are 19 semi-annual coupon remaining. The I by Y, that remains at 3.075. There has not been any rate change there is no indication that the interest rates have changed. So these details remain as they are. Okay. So with this, excuse me. Okay, so once we do this math, the present value of the security, the theoretical fair price of the security, comes out to 113.16, and this is on December 31. This price in December 31, which was the last coupon date, as with regards to February 15, 2021. So on December 13, if this be the price, 113.16, all that we have to do is to multiply it with the current yield up until to February 15, 2021. Because this is how it will be growing at the rate of the yield itself, so long it is on the price yield trajectory. So we know the yield, which is 3.075%. All that we have to do is to project them for the period of time between December 31 and February 15. So between December 31 and February 15, practically speaking, there are about 30 and 14, 44 days are there. So all that we have to do is to project this 113 multiplied by 1.44 divided by 180. Or you could also assume 45, because it is exactly on February 15. So 15 days would have been, so this is 45. So this is nothing but 113.16 multiplied by 1.03075 to the power 0.25. So once you do this math, this comes out to be close to 114.2. So this 114.2 is your theoretical fair price on February 15, 2021. Now, do remember that this 115.14.2 also carries that semi-annual coupon interest in the form of accrued interest, right? That's how it actually grows. All right. So now if we have to find out the modified duration, so we have to find the modified duration on February 15. all that we have to do is to shock this interest curve again, which is by 1 basis point on the plus side and 1 basis point on the minus. So here we already have found out the price on February 15th. Now, if the interest rate, if we have to find out the duration measures on February 15th, all that we have to do is shock this interest rate, okay, which was on December 31, the last coupon payment date. Shock this interest rate by 1 basis point on the plus side and 1 basis point on the minus side. So which means that in our calculation previously, all that we do is that we change the I by couple of times. So one, we make it as 3.08, and then we make it as 3.07, because understand, to 6.15%, if we shock it by 1 basis point, it will either become 6.16%, half of which is 3.08%, because it's a semi-annual pay bond, and the other will be 6.14%, half of which is going to be 3.07%. So we just input these details in our TVM calculation to find out the rise price, and we will then shock them accordingly. We will project them accordingly. So in this case, so we make it 3.07 first, just change this input, and voila, we get it at 113.323. So this becomes 113.238, or we call it 24. And another is that we change the interest rate to 3.07%, 3.08%. Now we change it, and we calculate it as 113. Okay. Okay. So now, given this, we find the modified duration. We take the projection for the next period. So this will be projected at 1 plus 3.08 to the power 0.25. I'm sorry, this will be projected 3.07, 0.25, and this will be projected at 1 plus 3.08 per 0.25. So if you do this math, let's see what it yields as 1.03 to the power 1.037, 0.0307. This becomes 114.1. So in this case, the modified duration becomes, as on February 15, 2021, this becomes 114.1 minus 113.86 divided by 2 into 114.2 into 0.0001. Okay, so if we do this math, so the new duration measure becomes 10.4979, which is approximately 10.5. Because since it's a semi-annual period, all that we do is that divide this modified duration, because this is annualized. So divide this modified duration by 2, so this becomes 5.25. So in this case, with the 12 basis point change in the yield, the money duration that is going to suffer, and the percentage change that it is going to suffer is close to 10.5 into 12 basis point would mean, in percentage term, is 0.2% only. So this becomes 1.26%. So 1.26% is the percentage loss if the experiences a change of 12 basis point either on the plus side or on the minus side. So if it is increase of 12 basis point, then the portfolio will suffer a loss of 1.26%. If it's a decline of 12 basis point, then the portfolio will gain 1.26%. Okay, so to just exemplify this in the money term, so it is going to be 114.2 into 1.26%. This so it's in absolute term is 1.43%, whatever will be the currency. Okay, so now we dive into the properties of bond duration, and this is an important thing as far as this slide. So for a fixed rate bond, let me start first with the fixed rate bond. So it's a smooth decline as the maturity increases. So if the maturity, as we proceed towards the maturity or the end of the tenure of a bond, the duration measure decreases proportionately. So if you have the Macaulay durations at each, but every coupon paying period, the duration drops drastically, and then again it slides up in the anticipation of the next coupon being received at the next resetting date. So it forms a sawtooth pattern, but it has a very smooth effect as far as the fixed coupon bonds are concerned. So fixed coupon paying bonds have very smooth duration measure that actually falls to zero as the tenor approaches. As far as the zero coupon bond is concerned, a zero coupon bond has its Macular duration, which is equal to that of the tenor itself approximately. A perpetual bond will have its tenor till infinity, and hence its duration is measured at 1 plus r by r. It's very simple. All they have to do is, if you recall this formula, a perpetual duration, a bond in perpetuity would mean that this expression within the bracket becomes a zero, and this expression outside the bracket also becomes a zero, because in the denominator out here, the exponential power is n, and n is, when n tends to infinity, this denominator becomes extremely large, so as to make the numerator look extremely small with respect to the denominator, and it approaches, as n approaches infinity, the numerator almost becomes a zero as compared to the denominator. Similar is the case here. No matter how much time has elapsed, t by t is always going to be zero as a t approaches towards infinity. So if we substitute this value, only this portion remains, which is the measure of duration for a bond in perpetuity. All other duration measures will be um, in between this zero coupon bond as well as bond in perpetuity. Let's just exemplify. For a bond that is being issued at premium, now these few properties out here of the duration are important from your exam point of view. So first we need to understand that the Macaulay duration of a bond in perpetuity is towards infinity. This extending to infinity is 1 plus r by r. And that for a zero coupon bond is n minus t by t. Again, if you just make use of this formula, all that you have to do is that for a zero coupon bond, substitute c as equal to 0, and you will get this expression for yourself. And a bond issued at premium, the Macaulay duration approaches as the time to maturity as the time to maturity increases, it approaches towards its maturity. The duration proportionately increases, and beyond a certain point, it flattens out. That means there is no further there is no further increase in duration. On the other hand, the discounted bond has a duration that is higher than that of the bond issued at premium. Why is it so? So I will make an intuitive explanation for all of you in order to understand that why is it so. See, for instance, forget all the formulas out here. See, for instance, if a bond, let's say, which is paying a coupon of C every resetting date, and at the end of the tenor, it's going to pay its last coupon and the face value itself. So if a discount, it is a bond issued in discount, but obvious that the discount rate is, or the yield to maturity, the discount rate is more than that of the coupon, right? So if the denominator out here by means of which you are discounting these cash flows is greater than that of coupon, the present worth of these cash flows will be proportionately smaller, right? Now, if you hold the bond till maturity, you are definite to receive the face value. The face value remains the same whether the bond is issued in discount or at premium. However, the majority part of the cash flows are now concentrated at the face value itself, because in the present value terms, these coupons are worth the worth of these coupons are significantly less than what it would have been if the bond were issued in premium. So you're receiving your cash flows, but you're receiving only small portion of your cash flow at each resetting period, and hence your duration to receive the entire cash flow increases proportionately. So that's why the bonds issued in discount will have a duration measure that is higher than that of the bond issued at premium. However, there is also a tipping point to this, and the tipping point suggests that the increase in duration for a discounted bond, just because the tenor increases, cannot go on indefinitely forever. So a point would come after which the bond issued in discount will become gradually insensitive towards as far as duration measure is concerned as the time to maturity increases, and it would gravitate towards the bond in perpetuity sort of duration. Similar is the case with the bond issued at premium, but bond issued at premium is pretty uniform in nature, unlike the bond issued in discount, for which the duration measure increases first, just like a bond measures issued at premium. Also, the duration measure increases first as the time to maturity increases. But with discounted bonds, since the present worth of those cash flows received are much lesser in comparison to the bond issued at premium, hence much of the cash flows are going to be received at the rear end of the tenor itself, and hence its duration is more than that of a bond issued at premium. So in continuation to that, there are 3-4 things that we need to understand. That there is an inverse relationship between the duration measure and that of coupon and the yield to maturity, and which is again intuitively correct. So if you're receiving high coupon, all other things remaining constant, the duration will be definitely lesser. So in between comparison, we need to understand that all other things remaining constant, as the time to maturity increases, the duration measure will also increase proportionately. As the coupon that is being received is more than all other things remaining constant, as compared to a bond which is yielding lesser coupon. If the coupon being received at each period is more than a bond where the coupon is lesser in nature. So that means that much of the promised cash flows are received now earlier than what was expected had it been a lower coupon bond. Hence, a coupon rate increasing would mean the duration will come down. So as far as the yield measures are concerned, if the yield measures are less, if the discount rate is less, that would mean that higher present worth of cash flows are being received earlier than the ones where the cash flows are received at much larger, at last portion of their tenure. So with this intuition itself, it's easy to understand that the relationship between the duration measure and that of coupon, yield to maturity, and the maturity itself. So I'll just summarize them here. All other thing remains constant. Coupon, if it is high, would mean duration is low. All other thing remaining constant. The rate to discount or the yield to maturity being high would mean the duration is low. Sorry, the duration is high. Duration is high. Similarly, the discounting rate being low would mean the duration is also low, right? And last is, if the tenor is bigger, the duration will also be more. Okay. So we take one more problem here, and it's fairly easy. The par values, and these are directly reproduced from the CFA text itself. The par values of bond A, B, C are given. Coupon rates are given. Time to maturity are given. Yield to maturities are given. Market values and the Macaulay duration. All other measures are given. So the total market value of the portfolio comes out to be 96.437. Each bond is at resetting date. That means there is no need to calculate any fractional accrued interest, and coupons are paid on a semi-annual basis. YTMs are also being stated on a semi-annual basis, and MAC durations are stated as annualized. So we need to calculate the modified duration of this portfolio first, and thereafter we have to enumerate the weighted average coupon, weighted average maturity, weighted average duration, and weighted average yield. The third question asks that if there is a yield change of to the tune of 0.2%, what will be the loss the portfolio will suffer? It is to be found out in percentage term as well as in absolute terms. So let us attack the problem one by one. First, we take out the first question itself, address the first question itself, that is calculating the modified duration of the portfolio. So we have been provided with the Macaulay duration. So from Macaulay duration for each of the bond, we can find out the modified durations. How do we find out? Again, application of the simple formula that Macaulay mod duration is equal to Macaulay duration divided by 1 plus periodic yield. So we have the Macaulay duration given, for example, for bond A at 4.761. This now divided by 1 plus 0.09. I mean, I'm converting the 9.1% into decimal form. This becomes the modified duration for A. Similarly, modified duration for B will be 5.63 divided by 1 plus 0.0962 divided by 2. And for bond C, it will be 7.652 divided by 1 plus 0. I'm sorry, this one is 8 is a 0.0962 divided by 2. So this becomes the individual modified duration of the bond. We need to also calculate the weight of each of these bonds, and that's pretty simple to do. The way we do it is weight of the bond A in this portfolio is nothing but 25 divided by 96.437. Similarly, for weight of bond B would be same 25 divided by, I'm sorry, this is the, we need to consider the market value. So the market value is 24.886. This one is 27.244. So this will be 27.244. This divided by 96.437, and this one will be 44.307 divided by 96.437. So if you calculate the weight in this fashion, the weight for bond A comes out to be, weights of these bonds for bond A, the weight comes out to be 25.8%, and for bond B it comes out to be 28.25%, and for bond C it comes out to be 45.95%. Okay, so if we have to find out the modified duration of the portfolio, all that we have to do is to take the weighted average of the each of these duration measure of bond A, B, and C. So for instance, the weighted modified duration for bond A would be whatever uh, this expression gives us, multiplied by the weight of 25.8%. Similarly, for bond B, the weighted modified duration will be 28.25% multiplied by this expression, and similarly for bond C, 45.95 into the expression that have been worked out. So if you do this math and then add all of them, the results comes out to be something close to 6.0526. Now please understand, this is the modified duration of the portfolio expressed in an annualized manner. Okay. So can we find out the weighted average coupon for this bond? Yes, that is also very simple to do. All that we have to do is to take again the weights, that is 25.8% for bond A multiplied by the coupon for bond A, which is 9%, and then again take 28.25% for bond B multiplied by the coupon of bond B, which is 11%, and we take the 45.95%, the weight of bond C multiplied by the coupon of bond C, which is 8%. I'll leave the calculation part to you. I think you should be able to do this simple algebraic calculation. In a similar fashion, we can find out the weighted average maturity. Again, weighted average maturity is nothing but take all of this weight and multiply by their individual maturity and add them up. Weighted average yield is also simple. Again, take the weight, all of them you will take the weight and multiply with their respective metric. So for yield to maturity, that has been given, for example, for bond A it is 9.1% multiplied by the weight of bond A in the portfolio. Similarly for bond B, similarly for bond C, and simply add them up, and whatever it comes out, that is our total, that is the answer to that particular question. Now we have asked to enumerate the portfolio loss, assuming that there is a movement in the yield curve of the security by 0.2%. So 0.2% on the plus side, that is what will yield us a loss. We have already found out the modified duration, which is 6.0526. All we have to do is to multiply this 6.0526 into 0.2%. So 0.2%, okay. Which comes out to be 1.21%. So this 1.21% is the portfolio loss for a yield curve shock of 0.2%. Now, to calculate the money duration, simply multiply the portfolio value, which is 96.437 into 1.21%. Which is equivalent to 1.67 currency units. Okay, so now we reached the last portion of the session out here, and this particular problem I would want all of you to work out and come back to me. As it is mentioned, severally Perpetual has issued a 15 years bond maturing on December 31, 2029. The bond has been priced to yield 8.5%, bearing a semi-annual coupon of 10%. It is July 13, 2021. Since the last coupon, the market interest rate has increased by 50 basis points. So again, the same problem as that of finding out the accrued interest at finding out the value of a bond which is not the resetting date of the bond itself. So anytime interim two coupons is what we are talking about. Considering the day count convention as 3360, and then it goes on to say that Mahesh Mathur has recently got promoted to vice Vice President Fixed Income in Abroli Investment, overseeing $500 million portfolio. This is his first major investment decision, and you are helping him make that decision. So calculate the issue price and the cash price of the bond on the settlement date. I'm sure that by now you would be in a position to calculate this. তুমি কি করছো তুমি এখানে বসে আমাকে ক্রিটিসাইজ করতে আমাকে পাগল করে দিচ্ছ তোমরা সবাই মিলে, আর আমাকে বলছে যে আমি কোনো কাজ করতে না। অবভিয়াসলি আমি কোনো কাজ করতে পারি না। আমাকে তাহলে একটা রুম ভাড়া নিয়ে আমাকে অফিস তৈরি করতে হয়। বেশ করেছি আমি। You should have thought all of this. Don't put it easy to put the blame on the others. সারা জীবন তোমাকে শুনতে হবে। হ্যাঁ পড়াবো তো, তাহলে তোমার কি সে? হ্যাঁ তোমার পুটকিতে জ্বালা ধরছে কেন? একটা ভিডিও করতে আজকে সারাদিন চলে গেল আমার, যেখানে আমি একদিন দুটো করবি এরকম। ডেফিনেটলি মৌ, তুমি এখন আমার কনফিডেন্স নিয়ে কথা বলবে। আমি এত বছর এডুকেশনে আমি এমনি পড়েছি। স্টুপিড ওম্যান। আমি এখন এখানে কাজ করছি মৌ, তুমি ফ্যান চালাতে পারো না। আমি জানি না তুমি কোথায় যাবে। ডোন্ট টক নাও।